Hey guys, Mr. Bouchard here, and I'm here to talk to you today about rocks. Rocks differ a little bit from minerals in that, remember, minerals are composed of elements. Rocks are actually made of minerals. So these tend to be a little more complex. We're not going to be looking so much at doing tests with rocks to figure out them apart. It's going to be more of characteristics that we look in the rock that determine whether they're sedimentary, igneous, or metamorphic, the three major types. So let's take a look at that and learn how to actually tell the difference. Okay, so a rock is basically defined as a naturally formed solid that makes up the solid section of the earth. Rocks are made out of minerals, and there are three major rock types, which remember are going to be classified on how they're formed. We have sedimentary, igneous, and we have metamorphic rocks. Okay, so very different in the way they form. They form in different places as well, which we will focus on in the next set of notes on the rock cycle. All right, so first in the grouping, the sedimentary rocks. So obviously composed of sediments. You can see little particles in these type of rocks if you look closely at them. And also they tend to form in large layers. So that's something that happens because sediments will pile up and then make a section of rocks. Okay, so these are big layers of rock units, which we'll be looking at. All right, sedimentary rock, clastic is our first type of them. That's when sediments of pre-existing rocks are deposited, eventually become solid. So clastic, also the word that we can use is called fragmental. You'll see that in the reference table. So fragments of other rocks form classic sedimentary rocks. All right, organic are not what you go to the grocery store for, organic produce. We're talking about organic as in formerly living material. So organic matter deposited eventually becomes solid and then makes your rock. And then chemical are dissolved minerals coming out of solution. So this will happen in seawater especially because again you'll have salt and some other stuff in the seawater that can settle out and form rocks. Okay, so formation, we look at cementation is one way that they form. So large solid sediments are cemented together by minerals and precipitate out of solution. Okay, so an example of that could be conglomerate, which is an unsorted sedimentary rock. All right, you can see that in the bottom left corner there. So unsorted means it's all different mixed sizes, whereas sandstone on the right is more of one size sediment, which would be sand size particles. Okay, so you can see the difference between sorted versus unsorted. All right, compression, compaction. So basically all the weight from the overlying other rock layers will push down on the pre-existing rock layers, and colloids, which are clay and silt-sized particles, really small particles, smaller than sand-sized particles, okay, are squeezed by the layers of the overlying sediment and water, and you end up with rocks like shale. Okay, so shale is a very smooth sedimentary rock, very small, fine particulates that make it, and so a little different than like a sandstone, much smoother. Chemical action are those when minerals are dissolved in water, get left behind, or precipitate out when water evaporates. And I mentioned this, evaporating seawater is how this happens. So it has to be a salty body of water that once was in that area. Sometimes it might have been an ancient ocean that was in that area, or sea level was different in the area. So be aware of those situations. Okay, so rock salt's an example, but there's also rock gypsum, I believe, and dolostone. All right, so there's a few different chemical formed sedimentary rocks. Okay, biological processes are when shellfish die in their shells, and obviously minerals from the water settle with it and fall to the ocean bottom and get compressed into rock. So an example of that would be chalk or limestone. All right, limestone tends to have a lot of fossils in it usually. It could be shellfish, it could be many different things. Also, dead plant matter could be deposited and compressed into a rock. So that an example of that would be one of our fossil fuels, like coal. All right, so bituminous coal. There's also another form, a metamorphic form called anthracite coal, which had undergone some heat and pressure. All right, but either way, coal is a fossil fuel, just like oil and natural gas. All right, it's just the solid form of fossil fuel. Okay, natural gas would be obviously gaseous, and then the liquid form would be oil. So those are three different fossil fuels that we find in nature. Okay, most sedimentary rocks are going to end up being clastic in nature, meaning they're made out of sediments. Some are actually going to have different size particles like conglomerate, so they will be clastic but different size or unsorted. Some sedimentary rocks have one size particle and are sorted like sandstone. Okay, some will also have organic origins, and they could be made of plant and animal parts or contain fossils. All right, so if you look really closely here, there's some shellfish embedded in this sandstone, it looks like. And then limestone also. You can see some other shellfish in this limestone. Okay, some sedimentary rocks form in parallel layers called beds or strata, like I was showing you in the beginning of the sedimentary rock description. All right, so layers. But again, when we talk about layers in sedimentary rocks, we're talking about the whole rock unit. It's not within the rock. Okay, so the whole unit of rock is called the bed or strata. Okay, now identifying using the reference tables, so different things that they're going to throw at you. Mineral composition, some minerals are monomineralic, which means they're made of one mineral. They're also made out of sediments in some case, which means they're clastic sedimentary rocks. Okay, so rock gypsum is made out of gypsum as an example. That would be a monomineralic sedimentary rock. Okay, particle size, if they are clastic, the size of the particles will determine which rock you have. Okay, so an example, sandstone is sand-sized particles. Siltstone is silt-sized particles. And shale is clay-sized particles. Okay, so here's the chart you're going to be using. So again, here's the breakdown. So I mentioned texture as being one thing. So that's clastic, fragmental. You also have crystalline textures, which remember those are crystal form sedimentary rocks. Bioclastic. Bio, when you see the word bio or beginning with bio, that means life. So those are formed from life or formerly living materials. Okay, grain size is important up in the clastic. I mentioned that already. Composition is not going to be as important up here though, because you can see they're made of many minerals: quartz, feldspar, clay minerals, fragments of other rocks and minerals. Okay, so if you do see that description, that could still put you up here, but mostly the ones at the bottom are going to be composition is going to be more important. Okay, comments, that's other information you might need to know with size of sediment maybe, or shape of sediment. So just obviously take note of that. Names, that's the name of the rock. And then map symbol is something we'll be using when we get to topic 13. So when we do rock layers and identification of them. Okay, down the bottom, chemically or organically formed sedimentary rocks, so the crystalline ones versus bioclastic. Grain size doesn't matter as much in these. You can see most of them just say varied. Composition though is very important, okay, because you can see these are all monomineralic, meaning made of one mineral. Okay, comments, this is also very important, especially with the crystalline ones. crystals from chemical precipitates and evaporites. So remember I mentioned evaporating seawater. So that's what evaporites are, particles from evaporating seawater. Okay, and then once again their names and symbols. And then bioclastic, the only different with these ones, the comment section, cemented shell fragments, biological origin, so for limestone, and then from plant remains, from, it's actually bituminous coal in the new reference table. Okay, so that's it for sedimentary rocks, and we'll continue on with igneous and metamorphic in the next videos.